Good day, Sir Afian. My name is Lee Chen, and this is my video presentation for MTS 3203 Mathematical Reasoning. For this project, I will present my alternative solution, which is individual one, using the algebraic strategy, and also in this presentation, I will explain the problem, the steps I used based on Polya's 4-step problem-solving method, and finally, the analysis and conclusion of my findings. Let's take a look at my problem first. I'll explain it step by step in the following slides. I choose the algebraic representation because it clearly shows the relationship between cost, length, and width using equations. This form makes it easier to organize information, identify patterns, and connect relationships between variables logically. It also allows me to reason systematically and avoid testing every possible value one by one. By using algebra, I can find the exact solution efficiently through calculation rather than through guesswork. Next, let's look at how we solve this problem using Polya's 4-step problem-solving method. In step 1, we need to understand the problem, so we can read the problem first. A farmer wants to build a rectangular field beside a straight river. Only 3 sides, 2 width and 1 length, need fencing. The cost of fencing is 10 ringgit per meter for the length and 5 ringgit per meter for the width. The farmer has a total budget of 400 ringgit and wants to use all of it. Find the integer dimension, which is length and width, that will give the largest possible area. After we reading that problem, we can underline or highlight the important parts in the problem to let us easier to understand the problem. So from the problem, we know that the field is rectangular and bordered by a straight river, so only need 3 sides need fencing. And the fencing costs 10 ringgit per meter for the length and 5 ringgit per meter for the width. The farmer has a fixed budget of 400 ringgit, which must be fully utilized. And the dimensions, length and width, must be positive integers. And the goal is to maximize the area. And the goal is, we need to find the integer, length and width of the rectangular field that give the largest area while using the full 400 ringgit budget. Next, we look at step 2 in Polya, which is devise a plan. To make the problem more solving friendly, I decided to express the total fencing cost in terms of L and W, which L is length and W is width. Since I already know the total budget, I can substitute that value into the equation. The cost equation contains 2 variables, so I planned to make L the subject, allowing me to substitute it into the area formula to form a single variable function. When this substitution is done, the equation becomes a quadratic, because multiplying 2 expressions that both involve W produces a squared term. A quadratic equation forms a parabola, and its vertex represents the maximum area. So I plan to use the vertex formula to find the value of W that gives the largest area. And after we get the value of W, we can get the value of L and also area. As the plan that we devised earlier, we can now carry out it step by step. And it's also Polya step 3, carry out the plan. First, we express the total cost of fencing as 10L plus 5 times 2W, and is also equal to 10L plus 10W. Since the total budget is 400 ringgit, we have 10L plus 10W equal to 400. And we can simplify it as L plus W equal to 40. And we can make L in terms of W, L equal to 40 minus W. Next, we express the area as a function of W. Area equal to L times W. we can substitute L equal to 40 minus W into the function. Area equal to, so we will get area equal to minus W squared plus 40W. From the area equation, we knew that A equal to minus 1, B equal to 40. Thus, we can now use the vertex formula W equal to minus B over 2A. Substitute A equal to minus 1, B equal to 40 into the vertex formula. So we will get W equal to 20 meter. Initially, we have an equation with two variables, L equal to 40 minus W, which now I've successfully calculated the value of W. Thus, I can substitute W equal to 20 into the equation. So we substitute W equal to 20 into L equal to 40 minus W, and we will get L equal to 20 meters. Therefore, we can get the area by using the area formula. Area equal to 20 times 20, which is L times W. So area equal to 400 meters squared. The problem required us to find the integer length and width of the rectangular field that give the largest area while using the full 400 ringgit budget. We can conclude that the 20 meters as length and 20 meters as width can give us the largest area. So we get the answer. To confirm the result, we use Polya step 4, look back. I check the total cost. 10L plus 10W equal to 10 times 20 plus 10 times 20 and is equal to 400, which is same with the total budget 400 ringgit. To make sure my answer is correct, I also plotted the graph of A equal to negative W squared plus 40W, which forms a downward opening parabola. The vertex at W equal to 20 visually shows the maximum area, confirming that my algebraic solution is correct. Next, we come to analyze and interpret the data that we obtained. The calculations show that the rectangular field's dimension of length equal to 20 meters and width equal to 20 meters gives the largest area of 400 meters squared, while using the full 400 ringgit budget. The area function A equal to negative W squared plus 40W is a downward opening parabola with its maximum at W equal to 20 meter. Confirming the results is mathematically correct and practical. The graph of this function illustrates the area peaking at this point, supporting the algebraic solution. Both methods verify the equal dimensions maximize the area. In conclusion, the algebraic strategy is an effective and logical method for solving this problem. It allowed me to determine the best dimensions accurately without testing each integer value one by one, saving both time and effort. The advantages of this approach are its accuracy, efficiency, and ability to show how one variable affects another. However, a disadvantage is that it requires careful algebraic manipulation, which can be challenging for some learners. Overall, the algebraic approach demonstrates how mathematics can simplify real-world problems, strengthen reasoning skills, and provide precise, reliable results.